Next we come to the close command. The close command releases a unit, an I/O unit number, so that it can be reused. I/O unit numbers are associated with files by the open command, which we'll get to in a little while. The open command associates a unit, an unused unit, with a file. We can then read or write to that unit, and when we're finished, we detach the unit with a close. Unit numbers were part of the original definition of Mumps, and more recent versions of Mumps may or may not use exactly this style, so you should check your documentation. Once a unit number has been closed, it is available for reuse. It is usually wise to release or to close a unit that's been used for output if it's no longer needed, because this flushes the buffers and makes the file permanent. The do command, which we've seen before, causes a dependent block to be executed. In the original version of Mumps, and still to this day, this was the form here, do, and you had a label. And what that would do is it would cause the program to pause and go to that label and execute the code at that label until either the end of file or a quit was encountered. When the quit was encountered or end of file, it would return to the do and do anything else that was on that line or move on to the next line. This was the original way it was done. Another variant of that is seen down here when you had do and you had a file name, in this case up arrow abc.mumps. That would cause the program to suspend, the file to be read in, executed until a quit was encountered or the end of file, and then return would be made to the original program at the point of invocation. In both of these cases, either branching to a local group or to a file, the symbol table was the same in the invoked group. The invoked area could see all of the variables that were present at the time of invocation. Likewise, the invoked area of code could change variables, could delete variables, and they would be seen when return was made back to the original section of code. There are other variations that have been added, the first of which was to create block structuring. You see that up here. We've seen it before with for loops and so forth. Here we have an if statement. If A is equal to B, do. What that do does is it invokes a block of code which is presumably immediately following. This is the form of the do with no argument. It has no argument. That tells it there will be a block of code following. The block of code has to have one additional indent level. So if we are at no indent level, no dots in other words, in the if, we're expecting to see the block of code defined by one dot. Now we can have blocks within blocks. So if I had a block within this block, it would have two dots, and it would have to be invoked by another do. If you do not invoke a block by a do, it just simply passes through it. It skips it. If I had if A equals B, write yes, something like that, with no do on this line, execution would go to whatever's past the block. It would not enter the block. It's required to have the do in order to enter the block. Then we've got this last form down here. This is again was added later in Mumps. You can invoke a block of code and pass to it variables. And there's several ways of doing it, and we'll look at it later. You can either pass by call by name or call by value. This obviously is passing a constant, so it's something that's not going to be changed, we hope. The invoked program will see the symbol table, but the variable coming in that's receiving this value will be local to the so-called subroutine. They're not really functions and subroutines in the same sense they would be in C or C++, because they still have the symbol table available. The else command we've mentioned a couple of times. The else command is not necessarily associated with an if. There does not need to be a preceding if. The else causes the remainder of the line to be executed if the value of $test is false. Now, $test is in fact set by an if statement, so it would be perfectly logical to have an else following an if. But $test is also set by the read command. If the read fails, $test is set to false. So, for example, if you were trying to read from a file and there were no more entries in the file to be read, the read would fail, and you could have on the next line else and do whatever it is you were going to do at end of file processing. The else, like the if, can have a do group. and blocks and so forth, the same as you would expect for the if. Notice since the else never takes any arguments, there's always two blanks after it. There must be two blanks after it. You can post-conditionalize it. Kind of gives you an odd sort of thing, but the post-conditional is legal here. The for command has several different variations, but essentially speaking, it's the looping command for mumps. The initial and the original version of it looks like the first line here. You had the keyword for, you had a variable equals, and you had a starting value, which could be a variable, a constant, or an expression. You had an amount of an increment, which was a constant or an expression or a value, and you had a limit value, the value up through and including what the loop would have. So if it was I equals 1:1:10, the loop variable would have the values 1 through 10 inclusive. On exit, it would have the loop variable would have a value of I, but inside the block or whatever was being invoked by the for, it would have values 1 through 10. Here you see some examples, the one I just gave. For I equals 1 by 1 to 10, write out I, and a new line character will write out the numbers 1 through 10. You could go in reverse. For I equals 10 by minus 1 to 0, and it would write from 10 down through and including 0. For I equals 1 by 2 to 10, it would write out 1, 3, 5, and so forth. If you leave off the limit, there is no limit. It just keeps going. It's infinite. So you need some other way to get out of it, and this loop doesn't have another way, so this is an infinite loop. What you would have inside of the body of the loop, it would be a quit, probably post-conditionalized, perhaps with an if, I don't know. More likely to be post-conditionalized. Loops can be nested. This was the original way of doing it, when they were only nested on a single line. There were no blocks in the original version of Mumps. So for I going from 1 by 1 to 10, we would write out I, colon, blank, and then for j going from 1 by 1 to 5, we would write out j, space, no new line. The new lines would only be provided when you increment I. So in the I portion of the loop. So this would basically, for each value of I, the entire value of the j's would be cycled, and the output would look like this. These are the values of I in the first column, and then you see the values of j in the second through fifth column. Sixth technically. You can have a comma list of values. For I equals 1, 3, 22, 99, value of I will take on those values during execution. You can have mixed mode. You could say for I equals 3, 22, 99, back to 1, 99 would be the interpreted, 99 would be interpreted as the starting point, 1 would be the increment, the upper value would be 110. So we would see 3, 22, 99, 100, 101, so forth, up to 110. You can have, again, this would be the infinite loop portion of it. We would see 3, 22, and then 99, and it would increment endlessly until something inside the loop caused it to quit. There is this is another form with no arguments, which is again a loop forever, but there's no variable running. For I equals, notice the two blanks, we would write I of course was initialized in the previous line. You would increment inside the loop. You would have a quit to determine whether or not to quit the loop and so forth. So this is an iterating loop, but it has no specific loop variable. The quit is used with for, as we've seen before. If I have this here, the for blank blank, meaning there's no arguments, and then a do, the do of course invokes this block down here. The block will write out I, it'll increment I, then we return to the for loop, and we would encounter the quit. The quit tests, or the post-conditional tests, whether I is greater than 5. When I becomes greater than 5, the for loop terminates. This quit applies to the for. So this loop is not a very efficient loop, but we will enter this block, we'll increment I, we go back up, test I. If it exceeds 5, we will quit. For this one here, for I going from 1 by 1 to 10, we would write out I. If I is greater than 5, we would quit. So In this case here, we would see I being written out for the first 5 values, and we would also see for the first 5 values the square of I being written out. Once I exceeded 5, we would not see the square of I written out, because it would quit before it got in there. The quit takes us out of the block, takes us back to the do, and then the loop iterates. So in this case here, we would see the squares up through and including I having a value of 5. After that, we would not see the squares. Next, we come to nested for loops. In the example in 37 here, we say an outer loop, which has the loop variable I, which ranges from 1 to 10, and then a do, which invokes a block. Well, the first line of the block is the write statement you see below, with 1 level of indent, and it writes out the value of I, a colon, and a blank. The next line in the block is another for loop. For j goes from 1 to no upper limit. It's an unlimited loop. And then there's a do. Well, that do will invoke the next block, which is the doubly indented a write statement, which writes out j and a blank. And then it returns back up to the invoking for. It goes to the quit. The quit will execute if j has become greater than 5. So we have a nested for within the block invoked by the outer for. The output of this you can see down below here. We have the 1, 2, 3, 4, 5 with the colon. These are the values of I. And then on the line are the values of j. You'll notice when we came out of the inner loop, we wrote a new line character. So that's the new line character after the 6s. And we get back up to here. The new line has already been written, so we don't actually have to write it here. We write it at the end of each line.